So we're going to go ahead, gross anatomy of accessory organs. We're going to talk a little bit more about the mouth and what it's doing. So mastication, chewing, and breaking it up. So it's the first step of the mechanical digestion, which is also going to happen primarily down in the stomach. So it's the first of the two. Our first oral receptors are going to be triggered primarily by sugar. We love sugar. We're all inherently addicted to sugar because it's super, super rare. Involuntary chewing reflex, so you don't have to think about it while you're chewing your food, right? You're not like chomp, grind, right? It just rolls, which is why you can chew gum, for an example. A handful of the muscles that are involved are going to be tongue, buccinator, orbicularis oris, and that's going to be what manipulates our food. For the most part, masseter, that jaw muscle that's allowing us to go up and down, masticate, right? Masseter. That's what's going to kind of be, and temporalis. Those are the two that are smaller, especially in humans, have caused all those kinds of changes over time. So next one is the chemical component, which is saliva. For the most part, it's water. For a little bit, it's enzymes. So we talked already about amylase. It loves sugar. Starch, chomp, 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 chews it right up. Okay, it goes instantaneously. It's what turns cotton candy into just absolute like paste in your mouth instantaneously. Lipase, like the LIP, that is like lipid, is what I want you to think of. So lipase enzyme is going to also is going to be activated by the stomach acid, and it's working for fat. Mucus is going to bind and lubricate the food. It helps you swallow it. There's not as much in there as obviously water. You're going to have some immune components or also components that are just going to manage the microbial community that is going to be in your digestive alimentary canal in your gut, right? Some of those are going to be lysozyme. Lyso means to break open or to split apart. It's working on largely bacteria. Immunoglobulin A is antibodies that are they're stopping bacteria from growing further. There's a handful of other items in there that are charged, such as sodium, potassium, chlorine, phosphate, bicarbonate, all of that. It's going to pH out pretty moderately, a little to the acidic side, around 6.8. Okay, salivary glands, we talked about these already, but I just kind of want to go over them one more time. So submandibular, under the mandible, again, that big jawbone of ours. Sublingual means it's under the tongue. You can see the little ducts of the sublingual ducts. So right when you take that first bite of something sweet, your mouth just fills up right away. You also get some from the back part, which we'll talk about, but masseter muscle, right, moving the jaw, as you can see right in here. That's most of kind of what I want you to look at here. Right there, so we kind of talked about the rest a lot. Extrinsic salivary glands, you have a lot of saliva all day long. If you're not swallowing about 1.5 liters per day, maybe drink some water, right? It's the dry mouth situation. So we'll talk about specialized cells that are going to filter water, the Acini cells, and electrolytes from the blood. So they're going to take the plasma component of blood, and they're going to be very selective, and they're pulling higher amounts of water for sure. And they're going to add in the enzymes that they're needing in order to start this process in the chemical level. Salivary nuclei in the medulla oblongata and pons. When you have food, especially sugar, that it senses, it's going to be sending the signal to create and secrete more and more mucus. Okay, even the thought of it, which is interesting. So this was, I won't get into this, but there were some psychology, classic and biology experiments using dogs, Pavlovian responses, where just like the sight or the smell of food will start you salivating because there is that brain component, right? So your observation of it. Keyword that I want to bring out is bolus, the food bolus. So now that you've chewed up some stuff, you've had that piece of pizza, you chewed it up, you've added saliva, so it's a little wetter. you've added some enzymes, so it's a little bit more chemically processed. We refer to it as a bolus, and it can become actually very thin and then get really compacted later down in the large intestine, but that is our keyword. So we're going to talk a little bit more about some of the sphincters and the pathway of the alimentary canal. So first, let's start up here. So this is the pharynx, which we talked a little bit about before when we talked about respiratory system. So it's just here, this very top part of the throat. We're not going into the larynx, so we're going down the esophagus, which is going to completely bring a tube all the way down, a muscular tube, all the way down past the diaphragm and empty into the stomach. Okay. The esophagus is about 25 to 30 centimeters long altogether, starting at C6, going all the way again through the diaphragm. It has sphincters. So what these sphincters are is we talked about a little bit like the hiatal hernia type thing. A sphincter is a set of muscles that allow a closure or an opening. They're a doorway. They are a guarded entrance or exit. Okay? It's usually circular. So it's going to be one of the ones that help kind of cut off, especially anything that's coming up from the stomach. So it works to finalize exit from the esophagus and entry into the stomach, preventing acid maybe from just coming back up, or it's directional flow. So when you have heartburn, for example, that means that the acid is getting past these sphincters, okay? And hiatal hernia is like pushing open that top sphincter. There's damage, okay? So swallowing, here's the process. So I don't know what this person ate that was green, but we're going to follow it. It's our bolus, okay? It's our bolus. So mastication has occurred. The tongue is squished it. The teeth have cut it up. The amylases and everything else is chemically processed it. We're leaving what we call the oral phase. We're pushing into the pharynx. Pharyngeal phase is that last swallow of the tongue. You know, that last push down swallow? That's beginning pharyngeal phase. It's going to push it back into the esophagus. As you can see, it's back behind the trachea, which is going to expand, and peristalsis is going to begin. Okay. Here's kind of an example of the esophagus closing back up during peristalsis, that contraction, and then opening back up at the very end after it's been completed, so that we can further travel that bolus all the way down. For me, I always think of like a tortilla chip. I don't know what it is, but every once in a while I'll eat a tortilla chip and I just didn't chew it enough or something, and I can feel that sucker scraping itself all the way down. And you know, it's after you swallowed it and you're just like, oh, I should drink some water or something. That's peristalsis takes that long. So that's what kind of I think of, and to kind of bring you into how long that takes. Esophageal phase ends once we've entered the stomach itself proper. The stomach is going to, again, we're going to revisit mechanically breaking up the food, and we're going to introduce this new term into it, chyme, C-H-Y-M-E. So what this is we've already digested this food bolus a little bit, and now we're going to further digest it, and we're going to add in some heavy hitters this time chemically. We're going to add in some acid. We're going to add in even more enzymes. So it's going to become thinner. Okay, that food bolus is now going to become much thinner. And it's going to slowly drip into the small intestine. We'll look at that in a sec, but real quick, volume. So the stomach is about 50 milliliters when empty, which like is not large, right? Is maybe the equivalent of like maybe like 4 or 5 bottles of nail polish normal size. It's not a lot. It's not lots. But it can really expand up to like a liter or 1.5 liters. So think of like, you know, this like an algae. It can get pretty big. It's not supposed to really extend past that. So when you think about portion sizes and how much you know you've eaten some of those days, it's like not supposed to happen. So this extremely full 4 liters. If this is always happening, this is, it can get very, very large. Your stomach will stretch kind of permanently. You'll have some permanent stretching there. So, it's something to be cognizant of in terms of health. Okay. So the stomach is a J-shaped organ, which we'll look at here real quick. Let me just kind of get in. So there's 2 images I'm going to show you. This is the first one. All right. So this one shows that J shape. It's like a bigger part of the esophagus, like a bigger part going into the small intestine, meant for all that mechanical digestion for the most part. This cardia part, think of it as being kind of closer to your heart, right? The fundus is that top belly, actually. It's like the top of the head, right? It's like the top part is the fundus. The body is the primary part, kind of sloping down, where it kind of like has, like the tush is what somebody called it once in one of my classes, and I think I do like that term, is the greater curvature. The pyloric sphincter is right here. That's another muscular doorway, right? The cardiac sphincter is up higher. That's a muscular doorway, an in and an out door, right? The rugae is all of the wrinkles that allow us to go from 50 milliliters to like 4 liters on Thanksgiving Day, okay? So that's kind of what I wanted to talk about there. Right. Pyloric part we're going to talk a lot about because there's some activity there, quite a bit of activity. So the pyloric canal is going to end at what we call the pylorus, and that's going to connect us directly to the first part of the small intestine, which we call the duodenum. Okay, duodenum. Right, and this is where we're going to start mixing in some secretions from like pancreas and gallbladder and all of that. You may have heard of Helicobacter pylori. It turns out we found one of the causes of stomach ulcers is actually a microbe. And it was detected in this region. And what it does is it's an extremophile. It's an acidophile, right? And a thermophile, really. And it was able to get in there and kind of starts tearing up at the cells, right? Okay. And hang on a second. I'm going to get into another video.